Nowadays, everyone has a microwave, and yet somehow none of us really know how to use it.
Have you ever heated up your food and it's just not tasting as great as the first time? Well, in this video, we're going to show you exactly how a microwave works and break down some tips on how to properly cook your food the right way, along with debunking some misconceptions some people have about microwaves.
So let's start with the basics. Here we have the electromagnetic spectrum. It consists of all known types of electromagnetic radiation. All the different types of radiation are categorized by their wavelength. So here on the left of the spectrum we have gamma rays, which are the shortest wavelength on the spectrum. These wavelengths are, on average, only 1/1,000,000,000 of a meter long, which is comparable to the diameter of an atomic nucleus. On the other end of the spectrum, we have radio waves, which are the longest of the wavelengths. These wavelengths are usually around 1,000 meters, which is proportional to the size of two CN towers stacked on top of each other. Microwaves fall just to the left of radio waves, with wavelengths ranging from 1 millimeter to a meter. Longer wavelengths are corresponding to lower energy, so microwaves have some of the lowest energy on the spectrum.
Now that we know what microwaves are, we need to take a look at the small stuff to see how molecules in our food are affected by microwaves. So here we see the atoms inside our food.
Wait, not those atoms. These atoms.
Oh, yeah, sorry. We see that the microwaves interact directly with the atoms in the food, giving them energy and causing them to vibrate. These atoms absorb most of the energy, but also release some as well. If the energy absorbed by the atom is greater than the energy released, then this results in a net gain of energy, and the atom's temperature will rise. This process of heat transfer through electromagnetic waves is called radiation.
Wait, what? There's radiation in my food? That sounds dangerous. Am I gonna get cancer from my microwaved food?
No! This is a common misconception among microwave users, but the truth is that there's actually no real danger to humans from microwaves. Microwaves are part of a group of radiation that is called non-ionizing. This is because it doesn't have enough energy to alter the molecular structure of you or the food. Similarly, there's no such thing as having radiation left in your food, just like how you don't have visible light left in your walls after you turn the lamp off. Now back to what I was saying. Heat transfer by radiation is the same effect that allows us to feel the heat of the sun without directly touching it. But due to the low energy of microwaves, they can only penetrate a few centimeters into the food. This means that only a small portion of your food can be cooked through heat transfer by radiation. But if this is true, then how is the microwave able to heat any meal at all? The answer is heat transfer by conduction. Conduction occurs when two objects with different temperatures come in physical contact with each other. When this happens, the heat of one object transfers to the other until they are both the same temperature. You might have experienced heat transfer by conduction yourself if you've ever been curious enough to stick your hand on the glowing stovetop burner. You probably would have felt that heat transfer to your hand pretty fast. That's conduction. Now, if we put all this together, we get the full picture. The microwave radiation gives the first few centimeters of atoms energy in the form of heat. These atoms then transfer this heat to the rest of the food through conduction, ultimately heating all of your food all the way through. Well, mostly. Now it's time for some microwave tips.
Tip number 1. For the times when you need to heat up a whole plate of food to an even temperature throughout, try spreading your meal evenly around the perimeter of the plate. The average household microwave consists of hot spots and dead spots, where they heat certain areas more or less due to constructive or destructive interference of the microwaves. Constructive interference is when the incoming waves add up with each other to create a spot of high energy, or a hot spot. Destructive interference is created from incident microwaves canceling each other out to create an area of low energy, or a dead spot. By placing your food evenly around the perimeter of the plate, it allows for each part of the food to pass through a dead spot or hot spot for an equal amount of time as the microwave rotates the plate. The most common dead spot in the microwave is in the center, which is another reason why it's best to place it around the edges.
Tip number 2. To make sure your frozen meal is warm even in the center, it's more efficient to microwave on a lower power for a longer amount of time than on higher power for a shorter amount of time. Since the microwaves only heat by radiation a few centimeters deep, the high power will be more likely to cook the outside a lot and the inside not so much. On a lower power setting for a long amount of time, we give the inside of the meal more time to heat by conduction without overcooking the surface of the food.
Tip number 3. To avoid moist foods from getting extra soggy, it is an easy fix to wrap the food in a paper towel before entering it into the microwave. Food gets soggy in the microwave when it has lots of moisture to begin with. This is because the microwave itself doesn't heat up on the inside. It just gives the water molecules in the food enough energy to vaporize, while also heating the food. And then when the microwave turns off, the water vapor loses that energy and doesn't stay in the form of gas. It condenses back into the liquid due to the lack of heating, making your leftovers taste soggy.
Tip number 4. To keep leftover pizza from getting too chewy after reheating, try placing a microwave-safe glass of water in with it. This will give you crispy crust like it's straight from Domino's. The cup of water acts as a dummy load to absorb some of the microwave so they don't all get absorbed by the pizza, causing the water molecules in it to evaporate and make it soggy. You may think the addition of water would cause more water vapor in the microwave, but this won't actually happen because to heat the cup of water to a boiling point, the water would have to be in the microwave much longer than the amount of time it takes to heat a slice of pizza.
We hope you learned something helpful from our video today. If you liked it, give us a like and subscribe for more videos like this one. Thanks for joining us.